and welcome. Kirsten asked us to come and do a little speaking to y'all to explain some of the things that we do in the Civil Air Patrol with unmanned aircraft and unmanned systems in general. My name's Austin Worcester. I go by SUAS for obvious reasons in CAP. So Civil Air Patrol is one of the best kept secrets in the Air Force. We were founded as an organization 1 week prior to the Pearl Harbor bombings. And then when the Air Force was born as a separate service, we became the Air Force Auxiliary. We are in all 50 states, Puerto Rico, the US Virgin Islands, and the District of Columbia. Our membership varies oftentimes in kind of a cyclical well, between 56 and 66,000 some odd members. We've been as high as 68,000 in the last year and a half. But we're supported by less than 200 full-time employees. That's what I do there. I manage the National Technology Center as the Senior Program Manager. And within the National Technology Center, we have Command and Control Communications, which is the largest communications system on the civilian side in the nation. We also have the largest single engine Cessna fleet in the world. And we're we used to say the single largest owner of small UAS. We're over 2,300 aircraft, but we've revised that to being the largest public safety entity now that Intel has about 10,000 aircraft that they register. But we do in UAS, our primary job in the Civil Air Patrol with our volunteer force is to relieve the warfighter of non-combat responsibilities. So we do 90% of aviation search and rescue in the United States that's tasked by the Air Force Rescue Coordination Center. We do Homeland Security missions, disaster relief, humanitarian assistance, counter UAS, and we can support and do support our DoD federal agencies, state and local partners, and occasionally some of the larger nonprofits. As I said, we have over 2,300 small UAS registered within the United States. There's over 2,500 Part 107 certificated pilots within CAP. Our mission pilots get 80 hours of minimum training and have to participate in at least 5 supervised missions, real-world missions, or training missions for us to be able to sign them off as a mission response pilot. I couldn't tell you how many folks are under our recreational pilots because we do aerospace education and STEM, particularly with our cadets. About half of our organization are cadets aged 12 to 21. And we have a mandate from our General Felka to provide that process through which and pathway through which a 12-year-old coming into our organization as an entry-level cadet can progress through our STEM kits into our mission response kits, into our advanced sensors, and come out the other side ready to go to a university and excel either at the academy or one of those universities that has an unmanned systems program and be very successful. So some of the sensors we currently employ, we do obviously electro-optical. Most of our camera systems are 4K or more. We do some multispectral work, long wave infrared, we do Lidar. We're currently researching ground penetrating radar, and I'll explain that here in just a little bit. And we like to say we're on the leading edge of the UAS community, but not the bleeding edge. Our budget isn't nearly big enough for us to be out there on that super edge of technology, but we do like to stay way out front and try to adapt to our mission sets as much as possible. So the type of aircraft we're using primarily right now is CAP has contracted with Skydio. When we originally started this program in 2015, we started as a program partnered with Homeland Security Science and Tech, and they created a pilot program in 15 of our wings and built aircraft on a hexcopter F-800 aircraft frame, and that had transitioned into DJI. And then as security concerns became very prominent with DJI, and the NDAA was passed that prohibited us from getting and purchasing Chinese-built UAS except for counter-UAS processes, we went with Skydio. We partnered with the Defense Innovation Unit, and were able to test all 5 of the blue UAS candidates prior to them being approved. Once those 5 were approved, we went with Skydio. So we use the Skydio 2 primarily for flight training and for corporate level missions. CAP is a little bit schizophrenic. We can operate as a congressionally chartered 501c3 under Title 36 of the US Code, but anytime we are working with a federal partner or for DoD, we are in our Title 10 capacity as the Air Force Auxiliary. So Skydio, the X2 Delta, is the version we currently use. We have about 50 of them fielded with a goal of 150 of them by the end of the next fiscal year. In our Title 10 capacity, security is always an issue for us. We're limited to Air Force Special Operations Command approved aircraft. AFSOC is the technical SME for UAVs within the Department of the Air Force. So except for counter UAS testing, training, and research, which we do participate in extensively, we cannot purchase Chinese-built UAS. And when we do that, we have to mitigate those aircraft with a DoD program for us to be able to use them. And it's not we hear it all the time from our civilian friends when we're working with them. You know, the common statement is it's available on Google. They could see whatever they needed to see on Google. So why are we this picky about security? But a lot of our imagery with CAP is far more detailed than would normally be reviewable from Google. Some of our imagery is working down to less than 3/4 of a centimeter per pixel for resolution. And it's about giving access to your networks inadvertently. We have fairly stringent security requirements in place to prevent us from accidentally releasing our imagery to somebody we don't want it to go to. So just so you know some of the stuff we're using, this is an Event 38 E384. It has a Sony R10C mapping camera or an XT2 thermal camera from FLIR. It has the flight characteristics and roughly the size of an RQ-11 Raven, but at quite a bit less of the cost. Its endurance time is 90 minutes, and it's designed to do about 1,000 acres per battery. It flies at about 20 miles per hour. And this is our large area. We use it a lot in blue roof missions for the Army Corps of Engineers, where we're mapping a disaster area post-event. We also fly the E386. The difference between the two is the E386 is equipped with a parachute, so it can be landed in areas that don't have a good landing strip. Typically, we need about a 50 by 150 foot landing strip area, and it lands on its belly. It has an ablative plate on the bottom of it to protect it. We also have the Instant Eye Mark III Gen 4, which originally went to was in use by the Marine Corps. It has both an electro-optical and a thermal imagery built into it. It's low resolution, but we do have the variants where I can put a high resolution 4K 640 by 512 thermal imagery camera on the side of it. And there is also what they call a heavy lift variant that can lift up to 3 pounds, carry it and drop it. With its mission battery, it can fly for up to 60 minutes. The T960 with the Lidar, that's our Lidar sensor, and we've done some work with that, and I'll show that to you here in just a little bit, mostly post-earthquake and mostly with FEMA. So in 2020, in January of 2020, the southern part of Puerto Rico was impacted by a strong earthquake, which caused a fair amount of damage across the southern part of the island. CAP's largest customer for IAA, or Incident Awareness and Analysis Imagery, is FEMA. And they use us as their aviation arm, mostly because FEMA doesn't have an aviation program within DHS. So they use us to collect imagery, both from aircraft, UAVs, ground, think Google car type imagery. And now we're looking at, from an unmanned systems perspective, mounting that to an unmanned ground system, similar to the robot dogs you've seen, to carry that Google car image in areas where we can't get a vehicle through. So in this case, the sewage treatment plant was identified as having some buckling by an aircraft. They dispatched one of our UAV teams who were on the ground in 10 minutes. And while that, what looked like buckling was actually shading, an optical illusion in the imagery, they were able to confirm that that was safe, but at the same time, they determined a concrete water tower was unsafe and about to fail. And so they wound up evacuating that section of the town. But that's how we work together between our ground, our air, and many of our other assets that we can put into play. One of the larger mission sets following Hurricane Michael, or Maria, was to evaluate the island of Puerto Rico's power grid. They are almost always in a single point of failure, and a contract had been let to repair the damage following the hurricane, and they found that things were not quite as what they'd hoped. And so they had us map with our fixed wing aircraft and our UAVs the 230 kilovolt and 115 kilovolt power grids. And what, as you can see, what some of the things we found in the bottom right, this was the largest project we did for FEMA. It took us about 6 weeks to accomplish, but it was so that FEMA could make a $60 billion decision on how best to repair the power grid in Puerto Rico. We're coordinating in a lot of our point clouds and imagery design, something called a Waldo Air XCAM. It's a pod-mounted high-resolution camera that the aircraft fly in a circular pattern over targets in a creeping line. They're flying at about 2,500 feet and getting very high resolution imagery. And we can add that in with UAV imagery to produce even more detail. In this case, this is post-flooding in North Carolina, where a bridge was damaged. And so, you know, we're working with our customers to produce 3D modeling, point clouds, sometimes animated design. And I'll show you some artificial intelligence work we're doing here in just a little bit. As far as Puerto Rico, when we were working with the Lidar, we were flying multiple targets with Lidar, primarily so that FEMA could compare the Lidar imagery they had from MIT, which was post-hurricane. I can't remember the name off the top of my head. There were two hurricanes, one and then Hurricane Michael, and then the earthquake. And so they were asking us to fly Lidar damage assessments over portions of southern Puerto Rico to help determine which disaster did this damage occur at. And I'll show you how they use that here in just a moment. But below is a cross section. It allowed us to look at a debris pile and help determine the size and quantity of that debris pile. One of the largest things FEMA deals with is debris removal. That's their biggest dollar item. Before, they were having inspectors stand and count dump trucks as they leave and then provide that estimate later on. Now they're using our imagery and doing volumetric calculations straight off of that, and it's saving tens of thousands of dollars in each disaster. This is the example I was showing you. They were trying to figure out which building was damaged by which disaster so that they could assign the money to the correct disaster. And that doesn't seem like much, but when they keep getting hit over and over again, it became a costing nightmare for them. But in this case, this particular building up in the right, you can see the green line, which was the LiDAR data from 2018. The red line shows that this damage was indeed from the earthquake and not from the hurricane. And we were able to get down to about 2 centimeters of shift to show, what buildings had shifted where. One of the other things we're doing frequently is we're taking damage assessment in tornado paths, most recently the Kentucky tornadoes. And what we're doing is we're flying the tornado path with the Waldo XCAMs and then doing specific targets such as critical infrastructure, power substations, bridges, things like that, where we want that higher inspection resolution with the UAV. And we can merge those into our processing software. And by doing that, we're getting extremely high resolution imagery post-event that we can then push to a contractor that we use to do remote damage assessment using artificial intelligence. And what it does is, through its algorithm, it takes, and we use USA Buildings as our base software for the shape of the buildings, the shape files. And then the algorithm determines, is the building unaffected, which is in green, to affected, which is yellow, to damaged, to heavily damaged, to destroyed. Destroyed is purple. And this is, you can clearly see the tornado damage path. Note up in the upper center of the picture, you'll see an airport. Just one of those things. CAP had an aircraft based at that airport, and it was destroyed when the hangar was destroyed. And so, we were conducting this quick damage assessment. What was the most interesting thing as we get a little closer here is we took this in during Easter last year in Mississippi. There were 2 days of tornadoes, and they had 2 EF3 and EF4 tornadoes pass within a mile of each other along a damage stretch. The state of Mississippi historically would take 2 to 3 weeks to get their damage assessments done in and make the application for a federal declaration of disaster, usually for public assistance money, sometimes for IA money. In this case, they brought us in to test for their, proof of concept within their organization that we could get what we wanted. And we were able to turn this stuff around to them within 48 hours, and they had their disaster declaration weeks in advance of what they would normally get. And as we get even closer, you can see how well the system does. It picks up blue roofs automatically, calls it affected. The problem with blue roofs is hides damage. And oftentimes we're flying a day or two later and people have already taken some action to protect their property. But by and large, if we can get in there within the first day or so, the algorithm works very well. From our stuff, you know, our lessons learned, you have to know the responses that you're going to plan to do and have the right equipment to do that. If our mission sets are so wide that we train for a wide variety of flight missions. Search and rescue, which is the one that everybody knows CAP for in the aviation world, is really a small part of what we do. It's actually the least amount of flying we tend to do, but it is the most technical. Imagery missions, we're flying automated missions, mostly using drone deploy and Q ground control. You have to have that right equipment and know what your customers are going to want. If they don't want, you know, if they're going to ask you to do something like Lidar missions and you don't have that, you'll have to have that quick way to get hold of that. But you have to train and fly and practice and practice and practice. And as always, build relationships. I always tell our folks when they're meeting with their local government folks, just to let them know that they're around, because most people don't know that the likelihood of having a local CAP squadron within 50 miles of their community is pretty high. And certainly within 100 miles, there are probably several units. But we have to build those relationships up ahead of time. And that's kind of how we wound up meeting with Kirsten here at ATARC to do a little discussions here and be able to answer some questions. You have to be self-supporting, especially in that disaster role. One of the biggest things we run into is we see folks who are really wanting to help out, but they don't know how to function in that major event environment. And so they're drawing down on already stressed resources in that local community because they don't have a place to sleep, eat, drink, don't bring their own food, don't bring their own water. And so they're stressing that system already. And many of them don't know the legal environment in which they're operating. Obviously, with us operating nationwide and in all of our US territories, the local legal requirements create some challenges for us. And you have to know how to get those waivers and get approvals quickly. We have an excellent relationship with the FAA. I can generally turn around the most complicated waiver requests in 4 hours for an emergency. And those usually involve beyond visual line of sight missions where we have to issue a UAS TFR or NOTAMs in complicated areas. We have flown within the Andrews Air Force Base Class Bravo airspace, and along with the 7 mile DC special flight restriction zone. We do a lot of work in both of those. So we figure if we can handle those, we can generally get what we need. But also be aware of the privacy and PII concerns. When CAP is operating in its corporate status as a 501c3, all of the Defense Department's regulations don't apply to us. And so a lot of our restrictions are lifted when we're working with state and local government. But anytime we're operating within that federal response world, it gets a little more complicated. Every year we have to have a defense imagery legal review done by NORAD Northcom. That sets about how we handle our imagery. Privacy and PII concerns, especially with the level of resolution we're doing, do become a concern because you can apply facial recognition software or license plate recognition software. And especially when we're in our Title 10 status, that gets into the legalities of quote unquote the US military spying on private citizens. The way CAP avoids a lot of those concerns is we don't own our imagery. It goes directly to the customer. So as soon as we take it, process it, hand it off, and they tell us it's acceptable to them, we scrub our imagery and we no longer have it. So it's up to our customer agency to address the PII and privacy concerns. Recharging capabilities for everything, 5+ batteries is sometimes necessary for some of these jobs. I do believe in backups to backups to backups. And our folks are trained as part of their mission pilot training to post-process their imagery themselves manually using a small suite of desktop applications. We never want to rely solely on cloud-based systems because we're oftentimes in areas that are so damaged that commercial internet access is denied in that short term, immediately post-event. Usually within 12 hours, our AT&T FirstNet comes up, or Verizon, or some of the other cell phone providers, and we regain our access to cloud-based stuff. But our folks have to be able to deliver imagery in the short term, no matter what. So our folks are trained to do that. We always say, stay within your limitations. Don't promise. We under promise, over deliver. It's difficult when you're in a profession that's so cutting edge and technology changes so quickly to not wow somebody. But you have to know what you can and can't do. And I also say, stay within the law. And that seems obvious, but in the studies we've been doing, 90% of the imagery we see is often obtained unlawfully, especially in the fire departments and law enforcement agencies. Many of them say, and I hear it said all the time, well, we're the fire department. What are they going to do to us? And so we're going to make sure we stay within the law. And you always have to understand what your customer wants and needs to know. When they ask you for what you're doing, you should be very specific and sit down with them. What is it that you want to see? Oftentimes we'll get a request because the customer flat just doesn't know. One request I had once from an agency was, well, we want you to image the Mississippi River and then the rest of the state of Mississippi. And we kind of looked at them and said, okay, let's manage some expectations here. When it was all said and done, they identified 60 targets they wanted us specifically to look at, and we mixed that up between UAVs and our traditional aircraft missions based on the size of the area that they wanted to look at. A lot of times your customer doesn't know what they want to know, so you have to sit and work with them a little bit. Follow up with them, make sure they got what they wanted. Oftentimes sit down with them. We'll sit with our customer side by side and say, okay, this is what you asked for. This is what we're looking at. Is this exactly what you want? And if it's not, we'll go back and refly it. Obviously, replace all media. That seems very simple, but we constantly see, even in our own folks, occasionally there'll be a whoops. They'll fly a mission with no SD card in there, and we wind up having to go back and do it again. This is my contact information. Our National Operations Center handles our defense support to civil authorities requests and all mission requests except for search and rescue. Search and rescue comes from the Air Force Rescue Coordination Center. Once they task it, they'll look at who the best asset is to go search for this missing aircraft or this beacon going off. And then they'll task either us or the Coast Guard or the active duty Air Force, any of those. So that's us in a nutshell and some of the things we're doing. I did mention ground penetrating radar. We are beginning to look at using ground penetrating radar in structural collapse. One of our many missions with FEMA is to support FEMA's urban search and rescue community. And so much like the recent condo collapse in Florida, one of the things we're looking at is trying to find a way to use ground penetrating radar from a UAV at a consistent height over top of a collapsed structure to identify potential voids and survivability areas. And so that's in the very earliest stages of that discussion, and we're kind of making that thought to see how that works.